I told you that one of the brightest stars in our night sky could explode at any moment? That's right, Betelgeuse, the famous red giant that marks Orion's right shoulder, might already have gone supernova, and we just don't know about it yet. It is a mind-bending thought, but Betelgeuse could have already exploded and we just don't know about that yet. The light from such an event could reach us at any moment, even as soon as tomorrow. Today we will be unraveling the mysteries of Betelgeuse. We will explore when Betelgeuse could go supernova and what would that mean to us here on Earth. Would that be dangerous? Then we'll also explore the recent radio observations of Betelgeuse and figure out why the star has been pulsating, dimming and brightening up and also speeding up suddenly. Let's get started. Do you know how big Betelgeuse actually is? If Betelgeuse were to be placed in our solar system, it would engulf everything up to Jupiter's orbit. Imagine a star so massive that it would swallow Mercury, Venus, Earth, Mars in just one gulp. Stars like Betelgeuse begin their lives fusing hydrogen in their cores. This is the main sequence phase of a star, and this is where stars spend most of their lives. As the hydrogen in the core kind of depletes away, the star expands and cools, thus becoming a red giant. Or for more massive stars like Betelgeuse, a red supergiant. This expansion phase is crucial. As the star grows larger, its rotation typically slows down dramatically due to the conservation of angular momentum. Just think of a skater that's extending their arms just to slow down their spin. So for a star like Betelgeuse that have reached towards the end of its life, the next step would be to fuse progressively heavier elements in its core until it reaches iron. In order to fuse more iron, you actually need more external energy. At this point, the core cannot sustain itself, it collapses onto itself, leading to what we astronomers call as supernova explosion. These are one of the brightest explosions in the cosmos. So if Betelgeuse were to go supernova, it would have been an unprecedented astronomical event in the human history. This explosion would be pretty bright, even outshining one of the brightest stars in the night sky, and would probably last several weeks. To give you a little bit of an idea of the scale we are talking about, our sun emits about 3.8 times 10 to the power 26 watts of energy. In comparison, the supernova detected in 2015 named Assassin 15LH peaked at about 2 times 10 to the 38 watts. That's equivalent to a combined brightness of 500 billion suns shining together. Now you might be wondering, with an explosion that powerful right at our cosmic backyard, should we be concerned? The good news is, at 600 light years away, Betelgeuse poses no threat to Earth. The danger zone for a supernova's harmful radiation typically expands to about 100 light years around it, so we are well outside that range. However, if a star closer to us would go supernova, it would be a different story altogether. Take Alpha Centauri for example, our nearest stellar neighbor at just 4 light years away. If a star that close would explode, it would shine as brightly as the moon and would bombard Earth with dangerous radiation. Luckily, Alpha Centauri isn't massive enough to end its life like a supernova, so we don't need to worry about such a scenario in the future. Now, take a moment and look at your watch. In that time it took you to do that, light from Betelgeuse traveled further than humans have ever ventured into space. That's just mind-blowing as to how far these stars actually are. Here comes the interesting part, and that has to do with some recent observations. Using the advanced ALMA telescope array, which is basically an array of telescopes working together to form one big giant dish, a group of astronomers have discovered that Betelgeuse is actually spinning much faster than expected for a star of its size and age. Here's the thing, Betelgeuse completes one rotation in about 20 years, which translates to its surface moving at about 5 kilometers per second or 18,000 kilometers per hour. For context, that is significantly faster than Earth's rotation. This rapid spin presents a puzzle. As stars age, they expand into red giants, and that means they typically slow down their rotation due to conservation of angular momentum. Betelgeuse's speedy spin, however, goes against that principle, challenging our modern understanding of stellar physics. Okay, now how did astronomers make this particular observation? Think of Betelgeuse as a giant cosmic merry-go-round. As one side of it spins towards us, it appears bluer because the wavelengths are getting squished and blue shifted. It's just like the higher pitch of an approaching ambulance siren. The side that is moving away from us gets redder, like a lower pitch as the sirens passes by, which means that the wavelengths of light are simply getting stretched. This effect is known as Doppler effect, and this is how astronomers actually measured Betelgeuse's surprising spin. So the million-dollar question, why is Betelgeuse spinning so fast? Brace yourselves for this shocking theory. Betelgeuse may have swallowed a companion star. Recently, a team of astronomers led by Zheng Ma just proposed this explanation. To investigate this particular spin, they used a sophisticated 3D simulation of red supergiants using a code called CO5 bold. They then developed a new post-processing package to create synthetic ALMA observations from these simulations. This allowed them to compare their simulated results against the actual ALMA observations of Betelgeuse. The researchers then mapped the surface of Betelgeuse by analyzing the Doppler shifts in the spectral lines of silicon monoxide (SiO) molecules in its atmosphere. The technique allowed them to create a detailed velocity map of the star's surface. Interestingly enough, their simulations showed that there's a 90% chance that a non-rotating star could be mistaken for one rotating at 2 kilometers per second or faster due to convection alone. However, accounting for this, Betelgeuse's rotation was still too fast to be explained by a normal stellar evolution theory. Rapid rotation observed in Betelgeuse could be explained by a past merger event with a smaller companion star. So when a large star consumes a smaller one, it kind of angular momentum on its companion, causing it to spin much faster. Imagine a cosmic dance ending in which one partner consumes the other, gaining not just mass but also angular momentum of its companion. It's like Betelgeuse decided to spin up by a cosmic cannibalism. This discovery isn't just about Betelgeuse, it's kind of forcing us to rethink how massive stars actually evolve. We used to think that most of these red giants were solitary stars, slowly puffing up as they age. But now we are realizing that many of these giants must have some kind of hidden history of cosmic collisions and mergers. Betelgeuse's story is just not about a star, it's about understanding our cosmic neighborhood and our place in it. Every time you look up at Orion's constellation, you are witnessing a celestial drama that is about to unfold. While we are safe from any danger, the prospect of witnessing a beautiful supernova explosion in our lifetime is pretty thrilling. What are your thoughts on this stellar mystery? Share your ideas in the comments below. And I talked a lot about radio observations. If you want to know how radio telescopes actually work, I literally climbed inside a radio telescope and explained in depth how radio telescopes, especially radio telescopes like the ALMA array, works. Remember to check that video out. It should be flashing here and should also be flashing in one of the flashcards. Links will be provided down below in the description. Until then, stay curious, keep exploring, and I will catch you guys in the next one pretty soon.